Medical imaging is the technique and process of imaging the interior of a body for clinical analysis and medical intervention, as well as the visual representation of the function of some organ or tissue. Medical imaging seeks to reveal internal structures hidden by the skin and bones, as well as to diagnose and treat disease. Medical imaging also establishes a database of normal anatomy and physiology to make it possible to identify abnormalities. Ultrasound is defined as high-frequency sound wave of 20,000 to 1 million Hz cycle per second. Diagnostic ultrasound operates between 3.5 and 10 million Hz. The concept of ultrasound differs from other medical imaging modalities in fact that it is operated by transmission and receipt of sound waves. Ultrasound is created by a high-frequency vibration of crystal located in the ultrasound transducer, which is a piece of equipment about the size of a small cell phone that is easily fit in the hand. The soft curved end of transducer is placed on patient and the gel is used to improve its contact with the skin. It is very safe to use and does not appear to cause any adverse effects, and is also relatively inexpensive and quick to perform. X-rays are a form of electromagnetic energy formed when high-speed electrons bombard the tungsten anode target. Like light energy, their useful rays have properties of waves and particles. However, X-rays have a much shorter wavelength than visible light, allowing them to penetrate matter. The body is composed of tissue containing many different elements, which vary by atomic number. The higher the atomic number, the denser the element, and the more effectively the X-ray is blocked. A magnetic resonance imaging instrument (MRI) scanner or nuclear magnetic resonance imaging scanner, as it was originally known, uses powerful magnets to polarize and excite hydrogen nuclei of water molecules in human tissue, producing a detectable signal which is partially encoded, resulting in images of the body. The MRI machine emits a radio frequency (RF) pulse at a resonance frequency of the hydrogen atoms on water molecule. Radio frequency antennas send the pulse to the area of the body to be examined. The RF pulse is absorbed by protons, cause the direction with respect to the primary magnetic field to change. When the RF pulse is turned off, the proton relax back to the alignment with the primary magnet and emit radio wave in the process. This radio frequency emission from the hydrogen atom on water is what is detected and is constructed into an image. Computed tomography CT scan provides us with images showing slices through the body. We can vary the thickness of these slices so that in effect we are looking at thin two-dimensional pictures representing a volume of tissue. It refers to the axial plane, the most common plane of CT imaging. In CT scan, a beam of X-ray spins around the object being examined and is picked up by sensitive radiation detectors after having penetrated the object from multiple angles. Computed tomography has almost completely replaced focal plane tomography in X-ray tomography imaging. Nuclear medicine encompasses both diagnostic imaging and treatment of disease, and may also be referred as molecular medicine or molecular imaging and therapeutics. Nuclear medicine uses certain properties of isotopes and the energetic particles emitted from radioactive materials to diagnose and to treat various pathology. Different from typical concept of anatomic radiology, nuclear medicine enables assessment of physiology. This function-based approach to medical evaluation has useful application in most subspecialties, notably oncology, neurology, and cardiology.